So today in class we continued with the lesson on 13.2, which was angles in the unit circle, and we focused today on the unit circle. The unit circle has a radius of 1 and is centered at the origin. Any triangle formed by the radius of the unit circle has a hypotenuse of 1. So this is a diagram of the unit circle here. So we have the red circle, the center is at the origin, and then this half of the diameter is 1 unit. So all the way around, it's 1 unit from the origin. So -1 if you go to the left or down, +1 if you go up or to the right. And if we were to draw a triangle that starts at the origin and goes out to the end of the circle, and we go straight down, that has a hypotenuse of 1 every single time. So one nice thing about the unit circle is that we can find sines and cosines of angles using the unit circle. So the point at which the terminal side of the angle intersects the unit circle allows us to determine the sine and cosine values of the angle. The cosine of angle theta, so that little circle with a line through the center of it, is a Greek letter theta, and we always use theta as like the variable for an angle. So the cosine of angle theta, is going to be the x-coordinate of the point. The sine of angle theta is the y-coordinate of the point. So I have 3 diagrams here, each with the unit circle drawn, and I have my initial side, which is a positive x-axis, and then the terminal side drawn as well. So in the first diagram, my terminal side is the positive y-axis, which is a 90-degree angle. And that point where it intersects the circle, that's 0, 1. Because remember, the unit circle has a radius of 1, so from here to here is 1. Well, the cosine is the x-coordinate and the sine is the y-coordinate. So the cosine of 90 degrees, my x-coordinate is 0. The sine of 90 degrees, my y-coordinate is 1. So that's what we see down here. So if I'm looking at negative 180 degrees, so negative 180 means that we're going clockwise instead of counterclockwise, has a terminal side ending here, and it intersects the unit circle at -1, 0. So that means that the cosine of negative 180 is -1, because that's the x-coordinate, and the sine of negative 180 is 0, because that's the y-coordinate. And then our third one is showing a positive 270 degrees, and a positive 270 intersects the unit circle at 0, -1. So the cosine of 270 is going to be 0, because that's my x-coordinate. And the sine of 270 degrees is -1, because that is the y-coordinate. So I want to talk really quickly again about the special right triangles. If we have a right triangle on our unit circle, the hypotenuse has the length of 1, because all triangles drawn on the unit circle have a hypotenuse of 1. So what that means for a 45, 45, 90 triangle, that means that this distance right here, that length, is equal to 1. So that means that we can figure out, if we know the hypotenuse, we know what the other 2 sides are. We just have to solve for s. So 1 equals s times the square root of 2, and then we divide by the square root of 2. So then 1 over the square root of 2 equals s. Now the problem here is that we can't divide by a radical. And I know you guys did this in geometry, but I know most of us don't remember it, but we have to rationalize the denominator. So we're going to multiply by the square root of 2 on both the top and bottom. So then we end up that s equals the square root of 2 times 1 is the square root of 2, over the square root of 2 times the square root of 2 is just 2. So that means that these 2 sides are the square root of 2 over 2. For the 30, 60, 90 triangle, we're in a similar situation. Our hypotenuse, if it's drawn on the unit circle, is still 1. And again, we can figure out what the other sides are because we can solve for s here. This one is a little easier to do though. So we would have 2s equals 1, divide by 2, and s equals 1/2. That means that the short side is 1/2 because that's s. And then the long side is 1/2 times the square root of 3, which we would actually write as 1 times the square root of 3 is the square root of 3 over 2. So I'm going to go ahead and redraw our special right triangles with the hypotenuse and sides drawn in. So again, for the 45, 45, 90 right triangle, our hypotenuse is 1, and then the other two sides were the square root of 2 over 2. I would draw that in your notes. And then for the 30, 60, 90, our hypotenuse again is 1. The long side is the square root of 3 over 2. And the short side is 1/2. Again, I would draw both of these special right triangles filled out with how they would be seen on the unit circle in your notes because you're going to use those. Looking at a couple of examples, we're going to identify what are the sine and cosine of the given angle. Remember that the cosine is the x-coordinate of the point that falls on the unit circle, and the sine is the y-coordinate of that point. So if our first angle is 60 degrees, that would be this angle right here. So our initial side is on the positive x-axis, and then we go up 60 degrees for our terminal side, and then we end up with this point right here. And we're going to draw a triangle. So we know the hypotenuse is 1 because it's on the unit circle, and all triangles on the unit circle have a hypotenuse of 1. And I know that that's a 60-degree angle. So if I look back at my 30, 60, 90 special right triangle, which is right here, I see that across from the 60-degree angle, we have the square root of 3 over 2. And across from the 30-degree angle, we have 1/2. That means that across from this angle here, that side is the square root of 3 over 2. And then this shorter side is 1/2. That means that that point there, because I'm going to the right 1/2, my x distance right here is 1/2. And my y distance going up is the square root of 3 over 2. So that's the coordinate point for the point that lies on the unit circle. So then to find the cosine of 60 degrees, it is equal to the x-coordinate, which is 1/2. To find the sine of 60 degrees, it is equal to the y-coordinate, the square root of 3 over 2. Looking at the second example, I'm looking at the angle of 225 degrees. So here's my initial side, and we go all the way around until we get to our terminal side right here. That puts the point right here on the unit circle, and we need to figure that out. In order to figure that out, we need to make a right triangle. So I'm going to draw up to the x-axis, over to the origin, and then back down to that point. So I'm making a right triangle. And then I need to figure out what this angle right here is. So the way I'm going to do that, I know that the total angle is 225 degrees. But to get to here, that's 180. So to get to 225, I would need to go another 45 degrees. So I know I'm dealing with a 45, 45, 90 triangle because that little angle there is 45 degrees. So then I need to figure out what the two shorter sides are. So I'm going to go back to my special right triangle and the 45, 45, 90 triangle, where again each side is the square root of 2 over 2. So that means that this side right here is the square root of 2 over 2, and this side right here is the square root of 2 over 2. So that means that that point will end up being, so note here, starting at the origin, I go to the left, the square root of 2 over 2, so that means that it's a negative square root of 2 over 2. And then I go down that same distance, so since I'm going down, again, it's a negative square root of 2 over 2. Which makes sense because this point is in the third quadrant, and both x and y are negative in the third quadrant. So then to find the cosine of 225 degrees, it is the x-coordinate, negative square root of 2 over 2, and then the sine of 225 degrees is also a negative square root of 2 over 2. Let's go ahead and look at two more examples before we really move on. So we, again, want to find the sine and cosine of the given angle. the first angle is a negative 45 degrees. So the first thing I'm going to do is draw that angle. So I start with my initial side. A negative 45 means I have to go clockwise. So that would be right here. So from here to here, that is a negative 45 degrees. Now I need to also draw my unit circle. And now I'm very bad at drawing circles, so no making fun of the fact that this is probably going to be more egg-shaped than anything. So here's my unit circle, and I need to figure out this point right here because that's where the terminal side crosses the unit circle. So I need to turn this into a triangle. So I go my hypotenuse, and I go up to the x-axis to make a right angle, and then over. So here's my triangle. Now I know that this angle is 45 degrees. So I'm dealing with a 45, 45, 90 triangle. And I know that the hypotenuse is 1 because I'm on the unit circle. So with a 45, 45, 90 right triangle, this side here is the square root of 2 over 2, and this side here is the square root of 2 over 2. So that makes this coordinate point. I go to the right, the square root of 2 over 2, so that's positive, but then I went down, so that would be a negative square root of 2 over 2 for the y-coordinate. So then the cosine of a negative 45 degree angle is equal to the x-coordinate, so the positive square root of 2 over 2. And the sine of a negative 45 degree angle is the y-coordinate, so a negative square root of 2 over 2. Again, we were able to find that coordinate point by using our special right triangles. So let's go ahead and look at the last example where theta is equal to 150 degrees. So again, I'm going to go ahead and draw my angle first. So I'm starting on the positive x-axis, and then I have to go to 150. Well, this would be 90, and then 180. So 150 is going to be about right here. So from here to here, that's 150 degrees. I also want to draw my unit circle. Again, no making fun of my circle. So my terminal side crosses the unit circle right here. So I need to turn that into a triangle, a right triangle. So I go down to the x-axis, follow the hypotenuse, the terminal side, and I go over. So now I've created my right triangle. I know that the hypotenuse is 1 because it is on the unit circle. I need to also figure out what this angle is right here. That angle, I know up to the terminal side is 150. And I know down to the y-axis, or excuse me, the x-axis, it's 180. So to get from 150 to 180, I need to go 30 more degrees. So that is 30. So now I'm dealing with a 30, 60, 90 right triangle. So now I just need to figure out what the other two sides are. Now the short side, which is across from the 30 degree angle, is 1/2. And then the long side, adjacent to the 30 degree angle, is the square root of 3 over 2. So that means that this point right here is going to be in the x direction. I went to the left, square root of 3 over 2. But because I went to the left, that makes it negative. And then I go up 1/2, and since I'm going up, that's positive. So my point is a negative square root of 3 over 2, comma 1/2. So then to find the cosine of 150 degrees, that's going to be the x-coordinate, so a negative square root of 3 over 2. And then the sine of 150 degrees is going to be the y-coordinate, which is 1/2. That's all this lesson is identifying the sine and cosine values using the unit circle and using the special right triangles. But I will see you guys in class on Friday. Have a great night or day.